Welcome to the Smart Factory.
So we are almost ready to the next session, and this time we have the wake up call for our American friends, right? So Steve, how are you?
I'll be really good here with another cup of coffee.
And Jake, what about you? Have you your coffees in place?
Yeah, that's right. It's tea time for now. We'll get to coffee soon.
And then energy drinks later.
Yeah, that is of course important. Very shortly, we're going to see your presentation, but before we do that, we have to get a little bit sooner, because I could hardly recognize you, Steve, because you have like a full beard and a little bit longer hair than normal. And is that part of being moving from being a executive from a world dominating lighting company into becoming a marketing technology guy? Is that part of the transformation for you?
I think like you've probably already talked about in some of your other sessions, is that, you know, COVID's accelerated a lot of things. And what I found personally is that it's been an incredible time to develop, to innovate, and sometimes you have to sacrifice a good shave here and there. But we've been having a lot of fun, despite the fact that we've been remote, and this is probably I don't want to say the permanent look, but this is kind of the as we're moving into the software side of the house, and some of the things that we're working on, which are.
But I can't help think about the next thing I will hear from you is probably that you exchange your Tesla with a Harley Davidson, right?
No. It would be definitely adding a Harley Davidson.
Of course.
But I'm holding out for the electric Tesla motorcycle whenever that arrives.
Oh yeah, maybe it will look like the truck. Who knows?
Yeah.
Jake, are you also in the same area of Steve, or you work remotely, or how is life from your perspective, except being early morning?
Yeah, that's right. We we're both based out of Minneapolis area in Minnesota, and since COVID, we've kind of foregone our office space. So I'll sometimes be talking to Steve, and he'll be at the cabin on the lake, and I'm always a little bit jealous about that. But yeah, life is good. It's different but good.
Before we also talk about the presentation itself, I'm a little bit curious, because I think that one of the things that you may have got a question from other than me is Baldwin, and in relation to IoT. Why is that?
I think it makes a lot of sense when we step into sort of the rationale, and I think, Morten, you and I have had some conversations in the past. How did Baldwin even come to be? And if you go back, it's been 102 years now since William Guggenheimer founded Baldwin, and it was really one of the first technology companies that created applications to enhance the process, to improve the print. In that time, it was a print production process, and it was automated blanket washing and cleaning. And it was a technology that just worked on all machines. It didn't matter which vendor or press you were using, but that was really the core of Baldwin. The history of Baldwin was founded on innovation of technology. And today, we all see where innovation is going. It's going to the data, the factory, the smart factory. And Baldwin has a great sort of luxury, so to speak, that we have technologies that touch all points of process now, in print still predominantly, but also outside of print and in new industry areas too. So it just kind of makes sense now that we're moving in this direction.
So if people think this is strange, is because they don't know you, and you don't know your story, and don't know where you come from, basically, right? I mean, the reason why I find that is interesting is because we are talking with the Smart Factory and Industry 4.0. We're talking about really exciting technology that can bring the industry to the next level. But I think that also in the same time, not directly related to it. It's also we live in a time where communication get way more diversified, right? Many different channels. You're working as responsible for marketing as well, and we also a couple of months ago spoke about being at trade shows versus not being at trade shows, how you use the internet to connect with people, how we use these kind of webinars, Zoom, and all these kind of things. So how does that influence your daily work and your communication with your customers and prospects?
I think in many ways it's accelerated that. I think there was a lot of wasted time. We look at opportunities to remove inefficiency and waste, and I mean my commute is about 60 seconds, these days, both directions. So you have all this extra time that you can spend towards advancing things. I think COVID I think you may have had a slide on one of your sessions, what was the thing that, revolutionized the digital transformation, and maybe COVID had more to do with that than anything. And so we were already underway, and I'd say that, speaking for Jake and the team that have been hard at work on this product that we'll talk about, it really is, if nothing else, has accelerated the velocity at which we're delivering these things. And in terms of communicating with customer, although nothing will replace the face-to-face interaction, we're all looking forward to that moment.
Fortunately, right? I mean, it's good.
the whole way, and the side conversations and all that stuff. But the networking I miss. But the the wasted time on flights and in airports, hotels. Some of it's refreshing that we can actually, I think the productivity of companies like ourselves has really gone through the roof, if we've treated it as an opportunity in that regard. So we welcome it. And again, we welcome coming back to some of the best aspects of, the face-to-face, and can't wait to get to that again. But we've got a lot that we can talk about now. So we've got a little bit of pent up things to show people and talk about.
And it's as a final note from my side before the presentation, it's kind of fun because you and I, we have known each other for some years now, and I think the last time we saw each other in person, that was actually in India.
I think
and it's just funny because also from the networking perspective, why did we meet in India? Is because you have something to deliver, and hopefully I had something to deliver as well. And that is also part of the communication, is that you maybe you have a little bit more. You maybe consider your time a little bit more precious in the future now, because you have to be a little bit more picky on what kind of events you want to participate in and what kind of face-to-face things you're doing. I just remember one more question. Of course, the Print UV conference has also been something of the EMS part, and I know that you have been deeply involved in for many years. Can you do that kind of virtual as well, or do you have to wait till you get physical with that?
Oh yeah, no. So Print UV, we're going to be making some announcements here in a short time. It's traditionally scheduled for the sort of end of March timeframe every year, and of course this year it didn't happen. But we're actually pretty excited about what we can do, because I think we're going to have a sort of a hybrid event where we will have people that will be able to travel, that'll feel comfortable traveling. The companies and spouses and girlfriends will allow them to travel, and we have some that will prefer not to, but still want to partake in the content. And so our plan for Print UV is to live stream events, but for those that are willing to come, to really have that networking, have that face-to-face, the dinners, the breakfast, the lunch conversations, the back of the room. Hey, I'd like to connect with you later. Discussions that you can really only have in that kind of a forum. And because Print UV is not a mega conference, it's several hundred people in the physical sense together. It's the kind of conference I think that should succeed in some respects with a hybrid way. So if nothing else, COVID will help us realize some dreams. We always had dreams of producing the content and having it available year round. And so Print UV on demand is going to be part of the new thing we'll do.
Fantastic. Steve and Jake, I will now turn off my camera and my microphone, but I will be listening to everything you say. And if you need any help, you just say, hey.
Okay, great.
and then afterwards, we have Q&A. I have prepared some questions. If there's anybody in the audience who wants to participate in the conversation or to ask questions, either click on the speak button or write your questions in the chat, and then we will get to you when Steve and Jake has done their work, right? So welcome on the Smart Factory Learn with Us event here, and looking very much forward to what you present right now. Thank you very much, guys.
Great. So I'll take it away. Let me know when you can see my slides.
We can see it.
Great. Okay. So, well, Morten, you kind of prompted me a little bit to talk about sort of the idea of connecting devices from multiple machines, and we've had a lot of conversations about sort of the importance of doing this in sort of this new future that we're seeing emerge and develop for our industry. And so, I hope that during the course of this discussion, and I really think it's more of a discussion and a conversation, that we'll talk about how this can be done and sort of, but why, maybe more importantly, why. So let me get started. So first of all, who is Baldwin and what is Baldwin Intelligence Group? And I'll talk about that here in a second. Secondly is connecting devices, or defining this problem. What is it? First of all, why is it? Why do we have a connection issue? Is it a problem? But I think maybe the question would be better to be phrased as, what if we could connect devices? And then, of course, some of my friends in the industry would say, well, great, but how is that going to help us make money? Because at some point we do this also for passion, but we also need to make sure that we're creating a business out of it too and making money. So we are creating a platform, and why does this matter? And I'll talk about the platform. I'll talk about what we're doing. In fact, Morten, this is a little bit of an exclusive. This is for you and for INKISH. We actually were planning on discussing a lot of this at the originally scheduled Drupa in June.
I'm not complaining, Steve.
Okay,
I'm telling you. Yeah.
So it's really the first time we've kind of gone a little more public about what we're doing and why it matters, and I'll talk about that. And then, of course, any questions depending on how much time and what they are. So just a little bit about me. This is my pre-COVID, look. Thank you, Morten, for finding a decent photo of me, I think. So I'm Steve Metcalf. I'm the Chief Marketing and also the Chief IoT Officer, the Internet of Things Officer for Baldwin Technology. And in a minute, I'll explain how I got here. But I also want to introduce a colleague of mine, Jake Schwertel, who's on the line on the call here. And Jake is effectively, I call Jake our chief technologist behind the development of our IoT offerings. And he leads a team in Minneapolis that's connected to a far-flung team throughout Baldwin around the world. And we'll be talking a little bit more about sort of the tech level of this as well. Just quickly, a snapshot of Baldwin. We are basically in the area of industrial process automation, and I always add the word enhancement technology because a lot of our technologies that touch process, predominantly in print, but in other areas too, touch them to make them better, to optimize them, to do things that may be more difficult for the manufacturers of the machines. So we don't make the standalone machines. We try to make the machines better and more automated and enhanced. And so the business segments of Baldwin have to do, in the classic sense, a lot of people who know Baldwin through the printing industry, we're cleaning automation, spray, dampening, treatment, surface treatment now, which largely is coming in the form of Corona Energy. Of course, there's LED and UV and infrared hot air drying, which is the segment that I originated from. Inspection, register, color control systems using vision technology. And then, of course, now what we're talking about is our new segment, which is the intelligence group. It's IoT, it's analytics, it's data for intelligence. And again, industry-wise, we're printing, we're moving more and more into packaging and converting, where a lot of us are focused these days. But a lot of our technology gets applied in textile finishing. And just a good example, the precision spray technology that you find on many of the offset machines that Baldwin's historically very well known for is also a great solution for applying things like durable water repellents on fabrics. And so we've really done some pivots in the last 5-10 years in moving into some new industries where that same type of technology, the precision application sense of it is really taking off. Film extrusion cleaning, other industrial markets, we're the largest supplier to some of the major manufacturers of flat panel display systems in the consumer technology world. So there's a lot of things that we're involved in these days, and we're still 21 locations. And one other point I'll make is that, while Baldwin is sort of a mid-sized company, we're part of a $3.5 billion global network of companies known as the Barry-Wehmiller Group, and we're kind of venture-backed, if you will, which I like to use as my sort of calling card for we're a startup again, by a company called BW Foresight Partners. That's the investment arm of Barry-Wehmiller. So That's kind of the snapshot of who Baldwin is today. And it's usually good to have just a picture of how Baldwin came to be. As I mentioned, William Guggenheimer, who's long since been very famous in the print industry, founded Baldwin in 1918 on the premises of automated washing and cleaning, and really expanded the business into the turn of the century, the millennium, through the growth of the print industry, while printing was still growing in all sort of facets. And then Baldwin really started to do more of an acquisition game, and in 2006 acquired OxyDry, which is still quite useful for a lot of print applications. Acquired Nordson UV in 2010. We acquired Web Printing Controls, was one of the dominant players in web print and process control in the United States in 2014. Of course, I acquired a company that was very near and dear to me, which is Air Motion Systems, in 2017 for the UV and LED UV technology. And then in 2017, also acquired a company in Germany that does surface treatment technologies, predominantly in hot air drying, known as Allbrands. And the 2017, Baldwin moved into vision technology, acquiring a company called PC Industries, which is a very well-known player in the inspection and defect detection game in the United States. And then QuadTech sort of capped all that. QuadTech was the technology arm of Quad Graphics that is well known for lots of technologies using vision and algorithmic control of print process, for registration control, for color measurement, workflow, and inspection. And so this is sort of what's gone into 2017. Well, now it's been 3 more years. So what have we been up to? Well, the first thing, just to kind of recap the product lines of Baldwin today, a lot of people may not be familiar with it, is that we've divided or sort of organized the product lines into 3 areas. So the vision area includes our color control, our register control, inspection, waste removal processes, a lot of workflow involved in that, web vision and color and ink management systems. And then the precision applications, the classic Baldwin, if you will, that's sort of been enhanced through acquisition, is involved in surface treatment, corona energy treatment of surfaces, cleaning technology. Baldwin is the #1 player in the cleaning game business arena in the world. Precision spray application technology, which was well known for spray dampening, but also now for all kinds of liquids and chemistries into industrial process, fluid temperature control systems, web enhancement. And then if you move over to our AMS spectral side, of course, the leading sort of technology today is LED UV curing, but we still are involved in quite a bit of conventional UV curing and putting together hybrid UV systems, infrared hot air drying, UV lamps and components. And what's really been happening here in the last 3 years, I'll pull your attention to sort of what's undergirding all of these things, is the intelligence layer. So one of the things you can do with a collection of these process touch points is begin to look at, instead of leaving data in isolation, what if we were to draw the data together that touches a machine through acquisition of it, and then through analytics and other applications, what we could do, and predominantly that's through an IoT initiative that began several years ago. Machine process and quality optimization is the goal. So that's kind of where we're headed with it. But this is a very unique capability that Baldwin can bring because of the fact that we have so many touch points in process, and gives us a unique vantage point also to develop out a platform. So with that, moving forward, I'll give you kind of an example. This is sort of today, if you look at a flexible packaging line, and by the way, we think that this idea of intelligence and this platform plays in almost every aspect of print and production and converting. But flexible packaging is a good example where a lot of these technologies come together on a single machine. You can see here a CI Flexo press that's probably printing pouches and bags and other things that are eventually going into brand owners and consumer products. But really what we touch is all kinds of things, from corona treatment to impression cleaning to curing to hot air drying, if it's a water-based process, a traditional UV and registration inspection, color management, ink management workflows. So we really have an example here where we can touch almost all areas of the process. So the question that this poses us is, what if? And this is sort of leading into your question, Morten, about sort of how do we connect devices. So I'm going to start with a few propositions, which is sort of what we started to discover ourselves as we were going through the IoT journey. What if you could capture all the data generated by your machines in real time? And so the machines are kicking off a lot of information. It's both live and it's historical. And so what if you could look at live information and begin to contrast and compare it to historical data? And you weren't just limited to some level of history, but you could really go back to since time began on the machine, since you started collecting this data. And then what if you could visualize it all together? And what if you could begin to understand the root causes of problems that you may have long suspected were there? Relationships of things that you knew were probably had some sort of logic or correlation, but you really could never put your finger on it. And so what if we could begin to surface these insights through the data that we're collecting on machines? And then, of course, what if you could compare and contrast your production process across your machines, across different makes of machines, different vendors? A lot of people don't standardize on one OEM. They leverage different OEMs, or they acquire machines from other companies. You have, of course, different operators. They have a huge variable there, skill levels and knowledge and experience. And of course, you have different plants. You have different locations around the world that may have different climates, that may have different other environmental variables. What if you could really start to see all this come together? And then what if you could identify very tiny trends that could have an enormous impact on your production quality? Things that may be very difficult for an end user or an operator to see until they become very noticeable. And by that time, when they become so noticeable, they probably already had an impact and have started generating waste or some kind of a production issue. So what if you get ahead of these things sooner than later? And here's one I love, and this is going to become what I would call table stakes for really everybody in our industry that's making machines, is what if you could eliminate the unplanned downtime altogether on the production line? That's not just for the press, but oftentimes the machine, the press itself is held hostage by pieces of equipment. One LED or UV dryer or one corona treater, for example, could really stop production if it was down. So you take a piece of equipment that maybe is 100,000 and 200,000 euros that's holding sort of hostage, almost like a terrorist, the entire machine, a $2 million production machine. And so what if you could eliminate that unplanned downtime and get it out of the system altogether? And again, getting on top of these trends before they cause problems. And so what if you could clearly identify the causes of waste that went beyond equipment uptime, waste that was process waste before it occurred, and you could resolve it? Digging a little bit deeper into that question is, what if your defects or waste was related to things that you could control, that might have been related to a multivariable sort of set of factors going on the machine and your production, such as your surface treatment, your energy, your color, your ink, your pressure, your temperature, your tension, your speed, your drying power? What if these things were related and you could begin to understand the relationships of them, and then again get ahead of the game in terms of preventing the waste long before it became a production issue? What if you could connect and merge the data that's being produced by your machine and all the components on your machine also with environmental data from your factory? What if you could start merging it with humidity and temperature and air quality and vibration and other things that are going on in the factory that could influence your production? So this is where we began to think about a platform. This is where we started to look at, instead of just doing this sort of on and again, Baldwin was developing a platform to begin to connect its own technologies together through IoT and data. But what if we could create a platform that went beyond that really allowed any device to connect? And looking again at the history of Baldwin in being a role player in the industry that was vendor agnostic. We didn't care. You bring your machine, we bring the technology to enhance the machine. And this is where the idea of AMP came from. So with this, I want to introduce AMP. So what is AMP? I think AMP stands for a lot of things to us, and it was a name that sort of developed as we were moving into this process. But it's an agile platform. It's something that we've developed very intentionally to flex, much more like an app that you'd see, a popular app, as opposed to a traditional rigid product development effort. It should be advanced. It should bring advanced technology and features to the process that we're trying to control. It should aggregate. It should be really good at aggregating information. And we'll talk about why that's important here in a minute. It should start to augment the process. So it really should start to give people that are, for example, operators, an augmented level of control of their machine. So instead of just running a machine based on the traditional HMI and sort of skill levels, it's really augmenting what's going on, augmenting the knowledge and experience of the operator, trying to put logic to as many things as possible. It's about creating ultimately this, moving us forward into this autonomous world where the machine is essentially starting to run itself. The process is correcting for itself, of course, with permission, of the machine operator, but moving into this direction of autonomous control of machines. And it's accelerating. It's accelerating our speed to market. It's accelerating the reduction of waste. It's accelerating the value that we can create for our end customers. And then you add the idea that it's for a machine and it's to control process, and there you have AMP. Advanced Accelerated Augmented Autonomous Machine Process. We could go on. I have other acronyms, but this is a good start. So why AMP? So in its core, AMP is an IoT platform, and there are lots of IoT platforms. If you go out and Google IoT platforms, you'll find just a litany of different companies. I mean, the biggest players in technology, you have Microsoft and Amazon and Google and IBM and SAP. Everybody is moving into IoT, and then you have a lot of the companies that are manufacturing the PLCs and control electronics are also getting into IoT. Everybody's got a platform. There's a lot of commercial, we call them commercial off-the-shelf IoT. So if you were the IT director or quality manager of your company and the CEO said, we need to do IoT, your first step would be to start Googling it and maybe talking to a few consultants, and you would probably be inundated with the alternatives and options. But I think what you find as you begin to go through this journey is that many of these IoT platforms are industry generalized, which means that they're generic. They're not designed for very specifically your industry. If we're in printing, and I'll put my printing and converting hat on, they're designed for agriculture, oil refinery, healthcare. You see a lot of platforms that are trying to be a one-size-fits-all to every industry, and that's a bit of a challenge. Once you get a hold of a platform, when you want it to do, a lot of them do basic gauging and dialing and sort of collecting and distributing of data fairly well. But when you start to want to visualize and make sense of data, put it together in a way that you can understand it and add value, they start to become rigid, and they're hard to customize. You may be reliant on teams of developers that have a lot of other priorities than yours. They're often proprietary and expensive or have hidden fees. So when you look at some of the offerings that are coming from these big companies, the idea is they want to hit you with an invoice up front before you've realized a single euro or dollar of value. They're looking for ways to monetize you before you've been able to monetize the solution. And so there are a lot of proprietary traps. There's some expenses that are hidden. And these things are things that you have to be aware of as you step into the world of IoT. And then, of course, because they're not tailored to your space and your industry and your process, they're going to require development. So this is going to take software skills that your organization may or may not have, engineering skills. And a lot of people then, of course, turn to consultants because they don't have these skills in-house. And if anyone's hired technology consultants, they know that it can be a bit of an expensive game. By the way, I'll raise my hand. This is the world I came from before I got into the print industry. Is I was in software development and technology consulting, and so I know how that works, and that can be a very time-consuming and costly process before you realize any amount of value. And then, of course, it's a complicated learning curve for end users. So as you see today, in the best apps in the world are apps that really don't require training. They're intuitive. They just people understand them the moment they see them, or like a good video game or something where you don't really need to read the manual. And so a lot of these developments with IoT require sort of a heavy learning curve with users. They were designed for engineers, not necessarily for end adopters. And we're taking a different turn here to try to make something intuitive. So the question we asked ourselves is, how can it be done better? And this is what led to the creation of the new platform called AMP. So what is the AMP advantage? And just to bullet a few things here, one, it's a new IoT platform that's specifically designed for the print process and so what's going on sort of upstream and downstream from print. Baldwin, in a lot of our technologies, that's our core business, so we understand it very well. So from the get-go, out of the box, it's off the shelf for the print process. Secondly, it's machine, vendor, OEM, device agnostic. So we really don't care where the data is coming from, whether it's our equipment, somebody else's equipment, the machine itself, other devices. It has to be agnostic and open. That said, it also has to be built on a very secure open source technology framework, so that the knowledge of the security of your data, as well as the platform that you're developing on, will open and scale. So as winners and losers emerge in the world of the IoT foundry space, the components that go into an IoT platform, if they change, we can flex and move to the new winners. Or if there's new cost advantages that can be leveraged, we'll move to those. So the architecture of AMP was designed from the get-go on what's called microservices. It essentially can scale, flex, be moved around. It's much like if you're developing a software company from scratch, what you would do. So we're not beholden to legacy architectures or proprietary technologies. We're not building it on Microsoft. As much as we love Microsoft for a lot of things that they do for us every day, we're not beholden to them. And it's allowing us to be nimble, flexible, and scale. And it's the same kind of development. It also allows us to be agile in the development process. So as needs come and change, we can sprint to develop the features that matter to the users of the app, so to speak. So AMP is also in the realm of focusing on the printing and packaging and converting space, is structuring the data to make sense to the print process and packaging process, converting process. And I'll give you some examples of that here in a second. And it connects not just to the presses, but really to any device that has data that could be useful to understanding the process. It delivers IoT insights quickly via what we would call preamp devices. So instead of having to go through a custom development process all the time, if there are popular machines and popular devices, we're going to go through what we call preamping them. In essence, developing the connector out of the box so that it's ready to go, so that somebody else doesn't have to do that the next time they run into the same machine or device. Obviously, with AMP, it's a very cool way for us to leverage the printing process know-how within Baldwin and also within our partners that's been developed over the last 100+ years. We know process, we know the nuances of the technologies that touch the print process in a lot of detail. We have technicians that have been out there for years working with customers. And if there's a way we can bundle that and leverage that knowledge faster across the industry, it's going to be a win-win for everybody. And the cool thing about AMP is that it can be used natively. So AMP will have a lot of visualization tools and analytics tools, but it could just as easily be pushed to a third-party system. So if somebody only wants AMP for the glue, then AMP can be the glue or the pipe. If somebody wants AMP to be the actual system for visualization and understanding, AMP can play that role as well and become an app platform, so to speak. So going into it a little bit, I promise this is the only technical slide, and I'm going to actually turn it over to Jake to give us just a sense of what AMP is if you kind of view it from a tech level. And of course, we'll be happy to talk about any technical level questions, but let's get into it just quickly and sort of describing it from a under the hood point of view. Jake, do you want to take over for a minute?
Yeah. Thanks, Steve. So like Steve said, I'll keep this pretty lightweight, but there's some important things that do kind of differentiate IoT systems. So like Steve said, AMP is a collection of microservices that work together to provide a useful, functional IoT system. And so there's a number of different services that we've built that have different uses. So the first one is flexible data ingestion endpoints. So this means we can take in data from anywhere. We use all of the industry standards, HTTP, MQTT. The important thing here is not really the acronyms, but these are used by everything everywhere. So that means no matter where your data lies, there's generally a way that we can bring it up into the IoT cloud very simply. Moving past the data ingestion point, we have a durable data pipeline that goes all the way from data ingestion to where you're visualizing or storing the data. And the keyword here is durable, right? So telemetry messages from an IoT device are persisted for months at a time. They sit in that pipeline and don't move. That means we can replay messages if any get lost. And we can, distribute these messages across different services without ever worrying about losing data. The important thing here is you never have to worry about your data moving into the cloud and somehow getting lost. It's not going to happen. The pipeline is durable. We have a web native tool set data visualization, which we'll talk about kind of some of the features here later. So the important thing here is web native, right? So from any browser, from Chrome on your desktop, on your computer, on your tablet, wherever you happen to be in the world, you can pull up our full end user tool set and use it to visualize, understand your data and your process. On the slightly kind of behind the curtains side of thing, we have a full tool set for monitoring the system health and usage of AMP itself. That means that we are faster to fix bugs, we're faster to support and diagnose issues, and it provides for a much not only faster feature iteration, but faster customer service. We have a full set of administrative tools. And so as we talk about, large companies that may want to administer AMP themselves, or just for, again, Baldwin themselves, we have a robust set of tools that allow easy partitioning of users, devices, customers, et cetera, et cetera. And the most important thing here is that AMP is available anywhere. So because of the flexible technology that we've built it on, AMP can live, currently it lives as a platform as a service that Baldwin offers, but we have all sorts of different offerings for self-hosted deployments or anything in between. So AMP is ready to meet you in the middle, wherever that may be.
Great, thanks, Jake. So getting a little bit more into the question that you posed us, Morten, is so AMP all the things. What if we can connect to anything, and how would that be done? And I think Jake, you might want to talk about here. So there's a process that ultimately is kind of a systems development kit that not only is Baldwin following in amping our own products, but that can be and is being made available to our customers, and can amp other things that are going into the data acquisition business. So. Jake, you want to talk about this quickly?
Yeah, of course. So the formula to build value with AMP is really simple. We can take data from anywhere because we are not proprietary, right? So whether that's a press, whether that's Baldwin equipment, and that's the easiest one to do, or even third-party equipment or environmental sensors, it doesn't really matter. We have a very simple startup guide to get your device connected to AMP. And to build value with that data and with AMP, there's a couple things that need to happen, right? So it's as most people will tell you, data alone does not create value, right? So we need to actually augment that data. And so to build a AMP feature to recognize some value from it, the data must first exist. So whether that's, again, in the press, on a PLC, some sort of add-on environment sensor, a Baldwin device, it doesn't really matter. The data must be accessible, right? So we're talking at a bare minimum internet connection and some sort of smart device, a PLC, a computer, to get that data into the cloud. The data must be usable, right? So it can't be overly noisy, though we do have ways to tame that. But the data must be coherent and recognizable in some way. And the most important thing here is data must be put into context, and that's where AMP really becomes valuable. A single data point alone especially is not particularly useful, but as you add a single data point to a bunch of other contextual data points, for example, what's the humidity in my factory? What's the speed of my press, and what's the power of my LED? Suddenly you start to create a bigger picture here where you can actually understand your process at a deeper level. So to create and really recognize value from AMP, we realized that data must be able to be understood in a greater context than itself.
Great. I'm going to sort of move a little bit more into my other question, which was, why do we care? Why would we want to connect all these things? And this is sort of the first glimpse of the AMP platform that the team here has been hard at work on in the last several years. And we did a little bit of a soft preview of this at Label Expo last September in Brussels, and got a lot of people pretty excited. It's come a long way, and we've begun to roll on our first live customers as well, which is exciting too. But AMP begins with this idea that you're sort of navigating data, whether you're a printing or packaging company, converting company, or whether you're a machine maker and you're monitoring all your devices out in the field. It's really the sort of view of the world, and it's kind of a little bit of a visual view. So AMP will be supported by geographical maps showing locations of machines, and then allowing sort of this idea to drill into a machine process really anywhere that it might be taking place. So the first element of AMP is what we call the machine navigator. And what you see here is just a way to, it's a digital overlay of your machines. It's a digitization of what we're familiar with, and the way that you and your team like to see the machines. I mean, we've all been in print plants so many times. We see the machines, and they need to be presented in a way that an operator understands them, that a quality control manager would understand them, that the owner of the company or the executive would understand the machines. So this is part of the navigation layer of AMP. So quickly navigate production status and the data that's being generated by the machines, and then view the production from anywhere you happen to be. So the beauty of being web native is that whether you're on your iPhone or your Android phone in India, or whether you're sitting at your vacation house up in the northern part of Denmark or the southern part of Italy, you'll really be able to dial into the machines. And during this time of the pandemic, when so many of us haven't been able to physically be on the factory floor as often as possible, this concept of being digitally connected to the machines and the data that they're generating is becoming really more very quickly acceptable, and that you're going to be connected to the machines in a way that you never have. So you're actually more connected to what's going on in the machine through a product platform like AMP than you would be if you were standing next to the machine, because you can see and visualize that data. The next layer, the next part of AMP is really what we call process radar. So if you're aggregating and through telemetry, bringing data in from all points of your machine, what can you do with that? And so one of the first things you could begin to do is put it together and aggregate it, and look at data from a standpoint of something we call process radar, which is, think of it as, the technical term is the telemetry values of data, the streams of data that are coming in literally down to the second or millisecond across different channels, and putting them together, whether you're looking at a specific area of the machine, such as your curing device, like in this case, an LED device, or whether you're looking at an inspection system and the two are related on the same machine. And you can begin to integrate and pull data together to see relationships across the machine and the process. So now you can begin to integrate information about the job, the operator, the speed of the machine, the shift, the pressure, the tension, the other elements of the machine that could be relevant that we can pull, the factory that it sits in. And then as you start to look at the devices on the machines, corona treatment, UV curing, drying, color control, color measurement, inspection, cleaning systems, all these other auxiliary systems that are generating data, we're beginning to pull that out and together. And then, of course, with the environmental aspect of process radar, you can begin to integrate data channels such as humidity of the factory, temperature of things, temperature maybe of your substrates, your rolls, the ink colors themselves, coatings, rollers, wash, water, etc. So all of these other environmental things can become very, very interesting to uncover insights about what's going on. We move another level deeper, we have device radar. So now if you drill in to the navigational layer, which you'll see kind of depicted at the bottom of the screen, you can focus in on a specific area of the machine. And again, when you look at the radar concept, you see this live view. The live view is this plot that's in green that's constantly changing across a selection of data channels or variables. In this case, if you're looking at the device level, it could be, the temperature of your device, the supply of water, the flow rates, other things that are valuable to understanding the health of that device at any given time and what it's contributing to the process. But then you also see this blue area in the back, this other plot, which is a historical reference. So you can very quickly visualize what's happening in the process, and is it deviating from some sort of threshold or norm. You put an operator in front of one of these sophisticated machines these days, and there's a huge learning curve to understanding process control. And in a way, AMP can augment the understanding of the process by providing the operator and the quality manager, other people that have access to this information, just an understanding, is the process doing what it's supposed to be doing based on sort of its historical reference value, whether it was last shift or since the job began or last time we ran the job, or since beginning of time. You can begin to tailor this sort of reference, this historical and live data comparison at the same time. And with that, you can begin to uncover insights and relationships and trouble spots very quickly. We can integrate the telemetry from any device on the machine, so additional channels of information can be brought together to analyze and aggregate across these channels. So that's the concept of radar that AMP brings in its platform. One of the things that any good IoT system should have is an ability to drill deep. We have something called the AMP Deep Chart, and really this is for the engineers, the quality managers. This is deep level analytics into structured data that's coming off the machine. So it's a tool set to allow us to surface the data and drill into it and across it very quickly and look for those relationships. And you can, again, see the process as it's unfolding live, and you can also go back in time using all kinds of filters and normalization tools that you would expect. And of course, you can download and export this information to other tools as well. But the deep chart is a fundamentally very important aspect of AMP. In addition to the deep chart is something we call AMP Zoom. And so if you're navigating a huge amount of data, one of the challenges that you'll quickly discover is that to be able to move around the data quickly and sort of the you are here map, if you will, if you're zeroing in on something that occurred, say, overnight or something, you want to be able to pull that information up. But you don't want to spend a lot of time getting lost in the data ranges. And so Zoom is something that's very unique to AMP that was developed that is not available on any commercial off-the-shelf IoT package that we've ever seen. And it allows you to really zoom in and out of very large sets of data with auto aggregation. So as you drill deeper and deeper, the granularity of the data gets finer and finer, and the density gets better. And if you drill out, we do auto aggregation so you can see the trends in a bigger picture way. So this is a very important part of AMP, is the Zoom feature. And of course, we've got the data views of AMP. So one of the things as you start to collect and visualize data, you want the idea of a dashboard. And any dashboard that's good is going to have a lot of customization and flexibility. So as you start to create and edit and rearrange your view of the process, you want to be able to have that, maybe share it with your team, organize it the way you would view the machine, and provide it maybe different views, the view that an operator might want to see versus the view that a quality control manager might want to see versus a C-level executive might want to see. And then, of course, being able to share these views, view them anywhere, and then customize them to provide the intelligence that you need. So the data view aspect of AMP is going to be one of the most important things that we can bring, especially as we look across the process connection and touch points. Data rules, alerts. So, this system is really designed to be preemptive and proactive. And so the ability to define and set rules about things that are good for your process, maybe that when your process is beginning to run off the rails, is going to be a very important part of AMP, setting thresholds, alarm levels of any value that we bring in through the telemetry. So it could be a value related to the production speed of the machine. It could be related to the power of the curing device or the drying device. It could be related to the inspection rate. It could be related to really anything that we're pulling in. And one of the other interesting things is that rules that can be created in isolation are one thing, but rules that can be created as rules of rules or nested rules become even more important. So we can begin to define rules that also bring in KPIs, historical averages, across different devices. So the idea of rules to control process is very important. And with AMP, anyone can essentially come in without a whole lot of training and begin to set these thresholds and levels of information. And then, of course, if you have thresholds and alarms going off, you want to be able to push it. And so AMP push is going to be an area that we've done a lot already and will continue to do more to be able to push data to any third-party platform, whether it's on demand, whether it's continuous, or whether it's rules-based. So whether that's IoT, another IoT cloud platform, whether it's the PLCs that control the machines, whether it's MIS systems, ERPs, CRM, Excel, whether it's Microsoft Teams, Power BI, data warehouses, cloud servers, custom development, AMP has got to be able to sort of live and breathe with everything else that's going on in today's IT ecosystem. And one of the cool things we're doing is adopting some of the most advanced middleware platforms. So if you're familiar with a company called Zapier. It's one of the leading cloud-based middleware tools. And Zapier allows a pre-built integration to some of the most popular ERPs and MIS systems in the world, such as SAP, Salesforce, CRM, Outlook. It also does all kinds of things off-road. So we already have a Zap hook developed into AMP, and we'll be doing more of that kind of thing to leverage the popular middleware platforms that is going to give AMP even more value to anyone who's using it. So what's coming with AMP? This is sort of a bit of a preview. Where are we? So the availability today with Baldwin, all the Baldwin technology products that we've covered and touched on earlier in the presentation will deliver with AMP IoT built in as a connectivity and as a standard feature. So it's much like you'd have with your Alexa device or something else. Any future product that we offer will be AMP ready and capable. And again, whether that's of value simply to visualize a point of concern data or to integrate it into a larger scale with multiple Baldwin technologies together on a machine, or to push it into a broader or other environment like MIS or ERP system, all of that can be done. We're working with our OEM partners. They can access AMP IoT to accelerate any of their own cloud initiatives. And you see pretty much everybody is moving in this direction now, specifically for their new machines that are coming with cloud technology, connectivity technology, and AMP is an enabler in that sense for many of the OEM initiatives. So we'll support and accelerate the time to market for a deeper, richer level of development for their own machines. We're also working with select device and software partners that can receive AMP in kind of the systems development kit or SDK for custom development on a priority basis. There are several really cool things that we're developing already that will be new AMP devices that we believe the market will, the print industry will welcome to have, things that start to get into that environmental realm of measuring and pulling data in. What else is happening in the factory? So you'll see some sort of level of AMP devices and software tools that will come along to support AMP as an ecosystem. And then, of course, this isn't any good until one of our customers, an end user, is actually receiving it and using it. And we already have a number of customers that are going live beta with AMP. And we're beginning to pull live our first customers that are going kind of across the machine and pulling data from the machine as well. And we're really excited. And this is sort of a segue into if anybody who is interested in talking to us about AMP and how you could deploy AMP into their environments, we are at a point where we can have those conversations and also drill down into a deeper level of what AMP is. So that is where is AMP. And at this point, I'll stop and I'll turn it over and say thank you, Morten, for having us here. And if there's any questions, we'd be happy to handle them at this time.
Thank you very much, Steve. I'm blown away, to be honest, because very comprehensive demo, which is perfect, our presentation. I also think that what really is great about your approach is the openness towards being vendor agnostic. I think that to me, it's like that is a new mantra, because sometimes we are asked to if printing companies want to open up for the media, for example, to film there, right? And I think that maybe 10 years ago, everybody was like, no, it's closed, kind of thing, right? I think that most people now start to understand that sharing values, sharing information, sharing data is part of the new way of actually ensuring your business. And this is the amount of data that you're able to capture, and also from so many different devices and so many different sensors, of course, enables everybody to get a full understanding of what you want to do. The question I have is a few things, basically, because I know from a fact that, for example, Psychio from Heidelberg, which also wants to connect vendor agnostic, I think that sometimes the openness is maybe from vendor to supplier, but from supplier to supplier, it's maybe not as open. The data that you connect, can that be used to give you competitive advantages in ways that vendors should be concerned about?
I think that there's maybe two parts to the question. One is like a Zychio it's there's different platforms that are emerging in print that are in theory independent of an OEM and a vendor. And the idea with AMP is that it's being launched by Baldwin or created by Baldwin, but it's we're doing it for the industry as much as we are to be more mindful and intelligent with the products that we put into the industry. But with Zychio, it's more of a supply chain platform where you're connecting, different tiers of supply, and what we're doing is drilling in and pulling and aggregating data from a machine level and pushing that. So the idea that there are probably a lot of touch points that we could have with that kind of a platform and other platforms that are out there emerging. Even a lot of our OEM partners are developing their own connectivity platforms. They have to. It's where the industry is going now. But AMP is an enabler to them. But we see AMP as a way to connect not just our own devices, and of course, if you go to Amazon and you buy an Echo Dot, you're going to have it's going to include the technology, right? That is Alexa. But there's so many other devices. If you think of the consumer world as an example of where IoT is flourishing now, whether it's your refrigerator or your television, they're all being enabled by this sort of Alexa or Google Assist or Siri, whatever you have. To a point where you may have AMP and Alexa communicating at some point, where you can actually go talk to one of the fun conversations I like to have with some of our customers is, imagine if you could come into your plant in the morning and or just do it over your Zoom check-in and just talk to the machine and say, hey, how did we do last night? What was your defect rate? And then you got an answer, much like you get the weather report from the
channel.
So I think it's more of the platform. Our industry is going to need a platform like this. We don't see anything like it out there.
I totally agree. I totally agree. But it's just like sometimes from when you are trying to be a journalist, you also kind of raise questions that could be raised from a company, right?
Mm-hmm.
Because I think that part of the success with AMP is also depending on how much the industry will adopt the technology that you are delivering, right?
Mm-hmm. Absolutely, yeah. And so with that, AMP has got to be sort of open and more like a consortium as opposed to a proprietary system. I mean, AMP is fundamentally, as we went over, designed to be non-proprietary, designed to be built on an open foundation. But much like any new sort of app or technology, it has to be kickstarted somewhere. It has to be started, and Baldwin was in a unique position to be the one to really provide some juice to it and get it off the ground. But you're absolutely right. A lot of it's going to depend on sort of the ability to adopt, keeping the cost low or to hopefully negligible for anybody that's going to be deploying it, and getting large scale adoption. But we don't see a standardized platform right now that is machine agnostic and vendor agnostic in our space, and that's what's exciting about AMP.
Another question is because if I don't know if you saw the session this morning with Horizon, for example, but when you look at the dashboards of the IceLink, it also had similar kind of the radar kind of measuring and temperatures and uptime and all the things, right? And I was just wondering, let's say that I'm a hardware manufacturer, but I'm not so strong in software, for example, and I would like to have IoT connectivity. Is that something where you think that maybe Baldwin also could be like an OEM of the IoT engine, where you kind of utilize maybe the software from AMP, but also the sensor knowledge that you have. So you can kind of because as I said before, if you really want the IoT and the Industry 4.0 to be globally available through all types of printing companies and devices and all things, the spread out of this needs to be a little bit faster than JDF, right?
Oh yeah. No, and I think that one of the roles we can play is through the Baldwin Intelligence Group is to accelerate those efforts. We talk to a lot of our partners, machine makers and so forth. They're hardware guys. That historically, they're moving into software at an uncomfortable pace. A lot of them, and it can be very, very costly for them to develop the teams of engineers that they need You know, and this is an upfront investment for many of them, because they're not generating any revenue stream. They're doing it just to stay in the game and be relevant. Because all new machines that are coming out now, it's going to be a level of expectation that they'll have this connectivity, that it's something beyond just the machine, but could be integrated with other things that are happening. And then you've got, of course, legacy vintage machines. You have other, you know, every factory you run into, typically you don't have all of the same model, make, and
oh yeah,
of a machine. So now you start to wonder, well, if I can get this great data from my new press, but what if I could get the same kind of data from my 5-year-old machine and my 7-year-old machine, and begin to aggregate that and look at it sort of across my facility, multiple facilities. I think that's where the idea that AMP can connect to anything becomes really important, and the speed at which we can connect the device kit, the systems development kit that is publishable to anybody who wants to connect a device to AMP, is going to be a very important part of it. The tutorials, how we do it, so you can spread that knowledge quickly, is going to be very important as well.
Our common friend Jacob Hiddedam Homel, he has a question, but before I will ask that question in public, and you may answer him. I don't know if you want to do that in public, but you but you can decide that for yourself. But just before that, one of the things is that what I like is that when you look at everything, looks so smooth and nice and very visually clear when you looked at the screens that you presented. That is one thing, and I'm getting that you get a lot of information that you obviously can turn into some actions in your printing company. One of the things that I believe that is really the promise of IoT is also the predictability of not just the operation of your printing environment, but also where your business is moving. Is that like also something that you have in your roadmap on how to do, maybe more kind of business approach, how to use the data?
Yeah, so I mentioned at one point that part of AMP is to not just measure a single data point. If you think of a lot of the data that's being through telemetry brought into the AMP platform, it's got a timestamp on it. So it's a series of data. The need and the ability to sort of connect it with business data. So what's going on, in the business right now? What job was on the machine? What operator, what kind of material was being used. Aggregate level information is also going to be a very important part of the AMP platform. And so as AMP adds value to business users, of people that are running a company, that are trying to make money, trying to reduce waste, trying to see where their process deviates shift to shift, you have to bring in that kind of information. So
but Steve, sorry to interrupt, but I think that maybe I was not clear enough, and maybe I have followed your entire introduction to this, but maybe I lost that part. I'm just saying that if you look at the information that comes from let's say the MIS system, or for the ERP system, or for the web to print system, I mean all the data that is, let's say that is the expectations of the finished job. I think that sometimes when we talk about all these technologies, how do you get from expected delivery to actual delivery, and how can you optimize that process? And I was just wondering, did I miss something, or did you also have some kind of because you have a lot of sensors on the machines and you show the machines, but do you also have a relation to the job tickets actually produced?
Yeah, so we do, and that's going to be the biggest expectation of our end users. So we've already gone down the path of showing them the engineering level information, and they look at us like, well, what am I supposed to do with that? And that's very useful for your engineers, your technical support people to stay on top of machine downtime and trends that are being influenced there. But to an end user, it's all going to be about running their business. It's going to be about correlating that data, tagging it to a job, tagging it to a shift or an operator, looking at plan values. My plan was to hold within these thresholds. How did I do, and how can I compare, and am I deviating over time? So those are absolutely in the roadmap of AMP, is to connect it to the business level data. And I know that type of information already resonates with a lot of people in industry.
Yeah, because you have the data, right? As Jake said that before, that one thing is that you need to have the data, but it also needs to be useful data, right? So obviously the job data is maybe the only thing that is 100% given from the beginning, right?
Right, exactly, and there are industry standards out there that can support it. Each major vendor has probably gone a little bit proprietary in some sense, but
oh no, you don't think so, right?
As we said before, AMP is designed to connect to anything, and it can
Yeah.
pull data from anything. It can push data to anything. So from that point of view, as long as we can put context to the data we're bringing in, then we can begin to visualize it together, and that's what makes it exciting. And I think that AMP is not a one-time product, of course. It's a software as a service platform. So it like a good app, it'll continue to have new features and rollouts. Most of them driven by what our customers are asking for and how they derive value from it.
It's kind of funny because now this is the third day we're doing these sessions here, and one thing that for sure has been repeated multiple times is that vendors need to be less egocentric when it comes to their equipment and data, because basically, as you know, most printing companies are not like one brand or one generation of technology. They often combine technology based on the applications they produce, and I think that AMP is a very welcome initiative in this. So I thank you very much for the introduction. Let's move on to Jacob's question, and as he is asking so long questions. Jacob, for heaven's sake. Well, I just read, and then hopefully you understand what he says. What would be the AMP in quotation process for a PSP? Will they get an AMP ID to access the platform through SSO? Often platforms in quotation takes time to use. So what are your thoughts to simplify the administration part of my AMP, but still get the value of what the platform delivers? Basically, I think that what he's asking is it easy to implement?
Yeah, I think so. So we've already been doing AMP, for the last several years at more of a device level, connecting devices of our own, Baldwin brands and technologies on a machine. So we've been, I guess I'd say it's not our first rodeo. We've run into this. How do you get something up and running quickly? You run into all kinds of things. So a print service provider, ultimately they're installing a machine or activating a machine. And the first thing you run into is network connectivity challenges. We can't, you have to contact an IT person to get that. So we've gotten really good at that. And actually there's new ways of providing these edge devices, if you will. So we look at, in the IoT world, you view a data collector as an edge device. So whether it's the PLC in a control cabinet, whether it's the machine control, whether it's a sensor, these are edge collection devices. And there's many ways now we can smooth out that. There's some things we're using which are that don't run on customers' networks, so they keep customers' data secure and go outside that. So we're finding ways of accelerating that out of the box, so it's much easier. But then getting the education, and AMP is simply making the platform available. It's setting up an access ID like you would for any cloud technology, and it can be pushed down to customers very easily when they subscribe to AMP. They can administrate their own users, and they begin to start in a way playing with the data right away. They can start visualizing what's happening on the machine, so long as at least one or more AMP devices are connected to the machine. And the more you have, the more AMP devices are on the machine, the better. And the better, the more the data comes together and makes more contextual sense. So.
Fantastic. Guys, I want to thank you very much for the time here. I think that AMS before Baldwin has always been a very, very good supporter to INKISH. It's very much thanks to your belief in us that we exist today. I think you are, at least as AMS, I think you are the one that has made most film with us, making sure that we could pay the bills and get to where we are today. And now this sharing of information that you're giving is simply just the way that we would like to have it. It gives our audience an opportunity to learn, to listen, to get wiser, and I hope that will help the industry to thrive. So again, both of you, thank you very much for your time and your eternal support of us.
Thanks, Morten. I really appreciate it, and this has been a lot of fun, and I can't wait to do it the next time.
Yeah, let's do that. Let's say thank you for this, and for the audience left, I just want to say thank you for participating. And this is the last session for today. But again, tomorrow we have the first session. I have to be thorough on your behalf because it's with me. It's a session about what is the digital mindset, and that is hopefully tying a little bit of the previous 3 days together, because first day was about what is IoT and Industry 4.0. Then we had the software. Now we had the hardware, which is also including with the hardware part of software part, of course. And tomorrow on Friday we will be talking a little bit more about the how to process this and how to get this under your skin. And we have actually also tomorrow we have, just so people know, we have Jacob and Anthony Thirlby talking about the customer journey on how to use this to make money with it. And then we have Geert van Dam and Peter Daunt from CERM. There's a MIS system for the label industry, but that was like a company that broke out of the Heidelberg just a month ago. So they are very keen on explaining what they want to do. And finally, we have a session with Diego Diaz, who used to work with the Bernard Group in Chanhassen, now working with ProPrint in Dallas. Maybe one of the most knowledgeable guys I know, and one of the guys that have really pushed the limits of Industry 4.0 in a time before it was actually called Industry 4.0. So let's watch the Baldwin video we did, and then again, thank you very much for everybody's participation, and yeah, have a great day and a great evening, and a good day to you guys in America. You have many hours ahead of you. Thanks. So stay healthy and have a good time.
Thanks. I appreciate everyone's time. Thank you.